Hello class, welcome. So today we're going to be looking at the second lesson in the series of chapter 12 on trigonometry. So we're going to focus on angles in this lesson. So different angles or different measurements of angles and how to convert between the two measurements, degrees and radians. Then we're going to briefly discuss the unit circle. All right, so our basic understanding or mastery is to be able to know what the different measurements and angles and convert between degrees and radians and a little bit of unit circle. So let's get started with the angles. The definition of an angle is formed by two rays. Okay, so remember, a ray is, this is how, so a ray is a point on one side and an arrow another. So basically it's an arrow. It has direction and it's only has one direction. So this is the end point and then that's the direction. So this is a ray. So an angle is formed with two rays. So in this case we have the two rays. We have this ray here and this ray there. So and they share an endpoint called the vertex. So in this example, this is my vertex. The initial side is where the angle starts, and the terminal side is where the angle ends. Okay, so this is the bottom is the initial side, and then you're rotating it at an angle to get the terminal side. So this space right here, is the measure of the angle. So the standard position is a position where the angle of an angle is when the vertex is in the origin. So in this case, this is the origin, that's where my vertex is. The initial side is the positive x-axis, and that's what we call standard position. So right now, this here is in the standard position. So this is the positive x-axis, and that's the initial side. All right, so that is standard position, and we're going to focus on drawing angles in the standard position. How do we measure angles? Well, angles are measured, positive if the rotation is counterclockwise. So if you're going counterclockwise, the angle is positive. So in this case, this angle is positive since it's going clockwise, or counterclockwise, I'm sorry. This right here is going clockwise. Oops. So this angle here is negative. Okay, so the angle is negative if you're going clockwise. So we're going to practice drawing these angles in standard position. So you want to draw an angle in standard position, then indicate the quadrant where the terminal side lies. So in this case, again, remember the vertex is in the origin. We have our initial side, and our terminal side is 50 degrees from here, and it's positive, so that means that this is counterclockwise. So that means we're going 50 degrees, and that's my angle. All right, remember that this is the 0 degree line, this is 90 degrees, this is 180 degrees, and then this is 270, and if you go back one circle, that's 360 degrees. So one full rotation is 360 degrees, and this is 50 degrees or less than 90. So therefore we are in quadrant 1. Okay, remember this is quadrant 1, 2, 3, and 4. Okay, so right now we are located in quadrant 1. For this one, this is negative, so this is clockwise. So we have our vertex, we have our initial side, and we're going clockwise, negative 120 degrees. So if we go down here, this is going to be negative 90 because we're going down 90 degrees. This is a right angle, okay? Remember, right angle is 90. And then a little bit past that, so this would be like negative 180 if you went down that way. So here we're at negative 120 degrees. So that's here, so negative 120. All right, so this is located in quadrant 3 because this is quadrant 1, 2, 3, and 4. So this is quadrant 3. Okay, I'm going to label my quadrants again. 1, 2, 3, and 4. So 500 degrees. This is more than 360, so you're doing more than one full circle. Remember, a full circle is 360 degrees. So you're doing, so this is your vertex, this is your initial side. You're doing one full circle and then a little bit more, okay? So that means you're doing, so one full circle is 360. If we do another 90, that would be at 450 degrees, right? So 360 plus 90 is 450, and we got to go a little bit past that. So that means we're here, we did a 90 degrees, and then a little bit more, about 50 degrees, and that's where we're at. So that means we're over here, and this is 500 degrees. So notice I did a full rotation, 1, and then I went back over here, and that's my angle. So let me draw the little arrow here so that you guys can see. All right. And that's counterclockwise. So this is going to be in quadrant, located in quadrant 2. All right, so that's it for the angles. So now we're going to talk about the two measurements for the 2 units of measure that we'll discuss for angles. So normally angles are written in degrees or radians. So these are 2 units for measuring angles. For the unit of degrees, we can think of it as breaking a circle into 360 equal parts. So each of these parts represents a degree, pretty similar to what we did here, where if we have a Cartesian plane, this first part is 90 degrees, then 180, then 270, then 360. So a full loop is 360 degrees. So full circle is 360. So therefore there are 360 degrees in a circle. For radians, however, we split it up in a different manner. So the way we think of a 1 radian, we think of 1 radian as the angle that is drawn when the radius of the circle is equal to its arc. So I'll show you how that looks like. So if we have, a Cartesian plane and we have a circle, right? So let's say, so let me draw the circle here, and let's say this circle has a radius of r, okay? So remember, the radius is the distance from the middle to any point on the circle. So that's the radius, r. So if we were to take a terminal side, or an initial side with a with a radius of r, and we were to travel 1 radian, then that means that the arc, an arc is this part right here. So this is that part of the circle. So radian is equal to where this radius is equal to the length of the arc. So this is a radius r, this is also a distance of r, and this here represents, this angle represents 1 radian, or 1 rad. So 1 radian is, again, is where you have an angle where the radius is equal to the arc that the angle travels. Okay, so the arc is this part of the circle, if you will. So this is like this part of the circle. So if like this were a circle, this is the angle that's cutting through that circle, and this arc here is equal to the angle, or is equal to the radius. I'm sorry, this arc is equal to the radius, and that is 1 radian. So it turns out that if we use this as our definition, there are 6.28 radians in a full circle. So if you were to do this, a few times, then you would have about 6.28 radians in 1 full loop, and that's the same as 2 pi. So there are 2 pi radians in 1 circle. So there and 2 pi rad is when you have a full circle. So you're doing 1 full loop. Okay. So how do we convert? It's easy. So you're going to use the conversion factor here, because remember, pi rad is equal to 180, right? So that means that if we have degrees to radians, we simply divide by 180 and then times it by pi. If we want to come from rads to degrees, we simply divide by pi, then multiply by 180. So let me show you how that works on here. So we want to convert degrees to radians. So what we do is we have 320 degrees, right? But we know that there are 180 degrees in pi radians. So basically we multiply by pi over 80 right here. That's what it says there. So what we do is we do 320 divided by 180 and then multiply by pi. Since this is going to give us a fraction, we're just going to reduce the fraction, okay? So this will be 320 pi over 180, and then we're going to reduce the fraction. So to reduce the fraction, let me go ahead and, so we're going to do 320 divided by, let's try, yeah, 320 divided by 2 would be 160 pi divided by 90. And then we can divide that even more, right? So we can divide this by 3, or not 3, 2. And this will be 80 pi over 45. We can divide this even more by 5. So 16 pi over 9, and then even more. So we can go even further with this. Oh no, that's it. So 16 pi over 9. So our final answer is 16 pi over 9 rads. All right, and that's it. So that's our final answer. So we just do this form and then just reduce it as much as we can. All right, so now let's convert rads to degrees. So we have negative 5 pi over 12 rads. But we multiply. So we know that there are pi radians in 180 degrees. So we multiply the rads. So now you see the rads kind of cancel. So we divide this. So now we know pi's cancel. So 180 divided by 12 is 15. So 180 divided by 12 is 15. 15 times 5 is negative 75. So this will be negative 75 degrees. All right, and that's your final answer. So when you have degrees, basically you divide by 180 times by pi. If you have rads, divide by pi times 180. And that's how you convert between those two. All right, the last thing that we're going to discuss, like I said, this is a real quick lesson just on degrees and radians, but we are going to discuss the unit circle. So the unit circle is a circle of radius 1. All right, so the radius of this circle is equal to 1. All right, so then what we do is we measure out the 30 degrees, 45 degrees. So these are all the angles in the circle. All right, so what we do is we're going to draw all different angles. So now this is 35 degrees, or this is the 30 degrees there. And we're going to convert the 30 degrees into radians, okay? So 30 degrees, remember we divided by 180 and then times by pi. So this is 30 pi over 180. So we got 30 pi over 180, but that reduces. So we can reduce this to, we could divide by 30 on top and bottom. And that gives us pi over 6. So that's pi over 6 radians. All right, so we're going to do the same thing here. We're going to convert that. So that's 45 times pi over 180. And then we're going to divide by 45 on top and bottom. And that gives us pi over 4. All right, same thing here. So we have 60 degrees times pi over 180. So I got 60 pi over 180. I can divide by 60 on top and bottom. And that gives me pi over 3. All right, and then 90 degrees. So we got 90 times pi over 180. So divide by 90 on top and bottom. We get pi over 2. So we got pi over 2. And then we're going to repeat the process. So we're just going to extend this, okay? So now we have another 30 degrees, but we know that 30 degrees is pi over 6. So we're just going to continue the process. I won't show the steps. I'll just write out what they are. You're going to do the same exact way. So like 120, then you're going to do times pi over 180, then reduce it, okay? Okay, so now we have, so this is pi. This is 3 pi over 2. And then if you do one full circle, this will also be 2 pi. So let me just, this is going to be 2 pi. All right, so if I do this, then this will give me 2 pi over 3. If I did this guy, I would get 3 pi over 4. If I did this guy, this will give me 5 pi over 6. If I did this one, I would get 7 pi over 6. This here would be 5 pi over 4. This here would be 4 pi over 3. Okay, and we got 3 pi over 2 here. So this is 2 pi minus 30, so that will be 11. Oops. Yeah, so 11 pi over 6. All right, and then this one will be 5, 6. This will be 7 pi over 4. So I'm kind of doing this mentally, so I'm trying to make sure I don't mess this up. So this is 3 pi over 2, 7 pi over 4. Okay, so this is 5 pi over 3. Okay, so again, you can do that. You can find all these angles using, this process converting. All right, and you do have to know what the angles are. So like if I give you pi over 3, you have to know that's 60 degrees by using the conversion factor. Okay, so what really helps here is if you know that pi is 180, you can swap out pi for 180. So like we know that pi is equal to 180, so basically replace that with 180, and 180 divided by 3 is 60. And that really does help facilitate this process. So here pi is 180, so then for this guy 180 divided by 2 is 90. So it helps out doing it this way. All right, and that's it, guys. So you just got to practice the unit circle values and then know how to convert between those two. All right, guys, take care and have a good day.